All right. So, getting back to math here. This shouldn't take this long. I think today's class will be like slightly shorter because we're just mainly going over some broad topics. So, first one, we're going to be going over solving linear equations. The most fundamental topic you'll need to know on the SAT. So, how do we solve linear equations, right? How do we solve them? Right? So what is the fundamental idea when solving linear equations? You want to have all the variables. Perfect. Good job, Alan. Yes. We want to isolate the numbers from the variables, right? So we want to have all the variables on one side and all of the numbers on the other side, right? So if I give you equation 3x plus 3 is equal to 7, what is your answer going to be? It's not a competition, guys. We're all working we're all working for the greater good. Right? 4 over 3, right? So we have 3x. We want to subtract 3 on both sides, right? So then we get 3x is equal to 4. X equal to 4 over 3, right? Simple stuff, right? These are the type of questions you're going to be seeing at the beginning of, like, at the beginning of your testing. I believe like the first 7 of, or not the first 7, maybe the first 5 of the calculator active section is probably the easiest you're going to encounter in your life, and then after that, it's going to get progressively harder. I think that's good. That goes to say with all the SAT questions, it starts really easy at the beginning and then progressively gets harder as you progress through the test. Same thing with the calculator active. You start very easy. I believe the first 10 questions are rather easy, and then as you progress through the questions, they're going to get progressively harder. I can't say that for the free response. So free response, I would say like they're typically like your middle hard. You know what I mean, right? They're not easy. They're not hard. They're like in the middle. They're like your mild questions, I like to say, right? So you just get all the numbers on one side and get all the numbers on the other, right? Or all the numbers on one side, all the variables on the other, right? Um, so remember, whatever you do to one side must be repeated to the other side, right? So remember, we have minus 3 on one. We have minus. If we have to subtract 3 on the left side, we must subtract 3 on the right side, right? And then same thing here, right? We have 3x is equal to 4, right? Sorry, I should have explained that. So we have 3x equal to 4, but we want to have x by itself, right? We don't want to have any coefficient, right? So we have to divide 3 on both sides, right? You can't just divide 3 on one side and call it a day. You must apply the same thing on the other side. I know this sounds very repetitive, but we're going to get into some tricks and some tips that SAT will throw at you, okay? So we have 3 and then x is equal to 4 over 3, right? Simple stuff. All right. So now we're going to move to inequalities, right? SAT, I feel like the inequalities, they're like moderately there. Some things you have to know. Like remember when you're using the greater than or equal or the less than or equal sign, the graph, if they provide you a graph and then they have the greater than or equal as the equation, is the line going to be dotted or solid? You guys probably already know this. I think it's like math 1, math 2 stuff. Solid? Yeah, it's solid, right? And if it's just normal like this or like this, what is it going to be? Dotted, right? So, oh yeah, keep open dotted. I don't know what diction your math teachers uses, but or your math teachers use, but that's the general idea here. Simple stuff, right? So one thing you always want to keep in mind, right? You guys already know this, but if you divide or multiply or divide by negative, what happens when you multiply or divide by negative? What happens to the sign? Sign flips, right? See, just very, very fundamental things, right? Very fundamental things. The sign flips, right? So let's say I have negative 3x plus 3 is greater than 7. What happens here? What is the not equation, what does the expression look like, right? It's not really a solution. Actually, no, it is a solution, right? X is greater than so and so, right? Oh, can you guys see it? X is more than, right? So we have negative 3x is 4x negative 4 over 3. Oh, I didn't mean to put that line there. Is that what you guys put? Yep, perfect. Yeah, easy stuff, right? Easy. All right, so I'm going to give you one question. I'm going to throw you guys in the water. here, and then if you guys don't get it, I mean, obviously I'll explain it afterwards. But here is the question I'm going to be presenting to you guys. It's going to have an absolute value. You guys already know what absolute value is. You guys know how to counteract those, right? So let's see how you guys do. For absolute value, 6 plus 2s minus 27 is less than or equal to -3. What is the solution set, or what values of s, like what should the range be of s in order for this to make sense, or in order to satisfy this expression? I'll give you guys like 3 minutes, 4 minutes on this, and then we'll move on to the fun stuff. This might seem a little monotonous, but it'll get fun, trust me. You become intellectuals under my don't know what to say. Yeah, essentially just solve it, right? There are going to be two solutions here, right? Yeah, so we split it into cases, right? There are two solutions. Yeah, just sorry, I messed up there. Just find the two solutions here, right? All right. So Drew, remember it's not an equal to sign, right? It's not. We're not. There's no equivalent sign here because remember we're still messing with a greater than or equal to here, right? So we don't put equals. It has to be an expression. Remember that, right? So remember, keep that expression in view. You guys are solving for s, but remember, I mean, not solving, but remember, I mean, when you do solve, you still have to keep that, right? X is less than or equal to 0. Okay, that's good. Or s, yeah, s is less, or x is less than or equal to 0. Perfect. Good job, Roshan. Is that how I say your name? Roshan. I'm not really good with Indian names. X is greater than equals. Yeah, perfect. Yeah, you guys got it. Easy, right? Easy. Right. So I thought I think when I first saw this problem, I think in 6th grade, right? The first thing that came to my head was like, yo, let's just distribute this, right? Distributive property. That isn't the case. Remember that. With the absolute value, you don't distribute the values here, right? You can't do that. It's not parentheses. It's not a quantity. You can't distribute the 4 into the 6 and 2s, right? You have to divide 4, right? I'm just going to do a quick rundown of this. So 4 absolute value 6 plus 2s. Add 27 on both sides, so then we're left with 24. Divide 4 on both sides, right? Because we can't multiply into the absolute value here, so that won't work. So then we have 6 plus 2s, absolute value of 6 plus 2s is less than or equal to 6, right? And then we have the two values where 6 plus 2s, 6, where s is 0, and then we have -6 minus 2s, 6, -2s, 12, I believe. S is 6. And then if you put that in, it would look -6, my bad. And then it would look like -6, 0, S. So it should look like that. That's how your answer choice is gonna look like, right? You guys can see my screen, right? I'm not just writing and having no meaning behind it, right? All right, cool. All right, so we understood that much. Sorry, I had to get the monotonous stuff out the way. Now we're gonna have some fun, right? So there are gonna be some special scenarios in which Neil, why not? Why not? We can't distribute the. Why not x instead of 0? Oh well, I mean the variable here is s, right? Wait, so why not x? So you have to test both -2 and 2. Wait, what are you guys talking about here? I wrote the final answer wrong. Wait, what are you guys seeing? Would you guys see -6 is less than -6 is less than or equal to? Oh wait, no, I did that wrong. No. Never mind. You guys are right. S is supposed to be in the middle. Oh, okay. Yeah, thanks for catching that. Yeah, S is supposed to be in the middle. My bad. Yeah, S is the middle. Yeah, sorry about that. See, we all make mistakes, especially me. I am master doing that. All right. So there are going to be some special vocabulary that the SAT utilizes when assessing questions, right? So there are going to be some special scenarios, and I want you to keep this in mind. Can't freaking type. So dividing by negative. So okay. So Prayag, dividing or multiplying by a negative flips. If you're dividing or multiplying by a positive number, it doesn't do anything, right? The sign stays the same. However, if you divide or multiply by a negative on both sides, then you have to switch the sign. Okay, or flip the sign. I don't know what I'm saying. Special scenarios. All right. So the College Board is going to give you an expression where a variable is unknown, right? They're going to give you an unknown constant, and then they're going to give you some extra content with that, right? So what I mean by that is that they're going to give you like 3x plus 2. 3x plus 2 is equal to ax plus 2, where where the expression above has infinite solutions. So if the expression above has infinite solutions, what is a equal to? Right? 3, right? Okay, so you guys do know this, right? I just want to give you guys some extra things, right? I mean, I'm going to give you guys some criteria on how to do this, right? So we have obviously a is equal to 3, right? So let me start with no solutions first. So they're going to give you 3 expressions here. They're going to give you no solution, one solution, and all or infinite solutions, right? No solution is when the coefficient on both sides are same, but the constants on both sides are what? Different? Right? Are different, right? Because when we have what? 4x plus 7 is equal to 4x plus 9. If we subtract 4x on both sides, we're going to get negative 2 is equal to 0x, and 0x is 0x, right? But x doesn't have any value at that point, right? So that's when it has no solutions. So, yeah, exactly. Same slope, different intercepts. I was going to talk about that when we go into the graphical component of this lecture, but that's perfectly fine. Yeah, same slope, different intercept. The best way to think about it. Good job. Right. So that's what happens when you see no solution. What about one solution? What do we see when one solution? The coefficients must be different in order for it to have one solution. That is the only criteria. The coefficients must be different. The coefficient of the variable, of course, right? So the way Nikki said it, so the slope must be different, right? So what I mean by that, if the left side had 3x plus 4, and the right side must have any value but 3, right? So let's put 9x plus 4, right? So we can still have the same constant on both sides, right? We can have the same constant because if you just subtract 4 on both sides, right, and then we have to bring 6x. So if we have 0 is equal to 6x, anything multiplied or 0 multiplied by anything is what? 0, right? So x is equal to 0. That's still a solution, right? So remember when they say that they're going to give you that there is one solution, that means the coefficients must be different, but the constants can be the same. All right. And then we have all solutions, like you guys said. All solutions, both sides of the equation must be identical, right? So whatever is on this side of the equation must be the same as this side of the equation. So if there is 3x plus 4 on this side of the equation, the other side must be 3x plus 4 in order for the expression that all solutions, that the thing has all solutions. Perfect. Yeah, Alan, perfect. Yeah, we're going to be talking about that later in the graphical component, where one is that and everything, right? Infinite solutions parallel. That's perfect. Yeah. Right. So what about this, right? So I'm going to give you 2x plus 4, and then is equal to a times x plus 2. What is the value of a? This might seem very easy. Yeah, zero solutions meaning parallel lines, and then same lines is going to be same line is infinite solutions, right? Yeah, perfect, right? This is going to be 2. Easy stuff. Right. So you guys learn stuff very quickly. Good job. Right? Neo, wait, why what? How did everyone get 1 and 2? 2 times 2. Yeah, okay. So look at it. Who is it? Prayag asked. I didn't even start. Don't worry, dude. All right, so we have 2x plus 4, right? So basically what we're trying to have is that a times x plus 2 must equal 2x plus 4, right? Because we're trying to have it so is that infinite solutions, right? So let's distribute the a, right? So we have ax plus a times 2, or 2a is equal to 2x plus 4. What times a? I know what times x is equal to 2x? 2, right? So that gives us our answer. That means a is equal to 2. Because if a is equal to 2, that means 2 times a is also equal to 4. So it'll be 2x plus 4 is equal to 2x plus 4. And that gives us infinite solutions. Right? All right. Are there any questions so far? Any questions on the special scenarios or anything along those lines? I am going to move myself down here. All right, let's go on to the second thing. All right, so I personally had a lot of problems with these. So I am going to hold on, guys. Sorry about this. A few people. All right, so I had a few problems about these. Right, so we are now going to be talking about inspecting a linear equation, right, or interpreting linear equation. So, hold on. Let me take this out. So, do you guys see my screen? Yes. All right, cool. So let's say we have, oh, by the way, the concentration it's supposed to be blank. The concentration of the amount of questions that you're going to be receiving on interpreting or like these type of word problem type of things are like 1 or 2 questions max on the whole mathematics section, right? You're not going to get a lot of these, but it's very helpful, right? So let's say, I need to make an equation on top of my head. Okay, so C is equal to 1.5b plus 62.5, where C is the total cost of books produced, and B is each additional book produced, or right? So obviously this is going to be in dollars, right? This is going to be in dollars. So what can we say about this? What do we know about this equation so far, just based on that? So 62.5. Okay, so Nadia, you found the trick, right? So in order to make one book, it'll be 62.5 plus the 1.5, right? Then that would be 64. However, 0 books, like Nikki suggests, is going to be 62.5, right? If you produce 0 books, you're going to have it's still going to cost 62.5. Oh, well, I meant, yeah, I kind of phrased that wrong. My bad. Yeah, but extra books are 1.5 each. I meant like the production of each book, but yeah. So now you got that. That's my bad on my part. Not each additional book, each book produced, right? Don't know why I put additional. Each book produced, right? Right. Yeah. So 62.5 will be the flat fee to produce any books, and then after that, Essentially, I don't know. I just thought of this on top of my head, so we're just gonna go with what we have. All right. So what is our slope here? 1.5, right? So what does the 1.5 suggest, right? So what does he mean by 1.5? So in ways that you should think about it, right? So $1.5 per book, right? Exactly. Cost per so it's essentially a cost increase, right? So for every book you for every book you produce, or like for every one more book you produce, it's going to be $1.5 more, right? So what I mean by that is that if I produce $1 or one book, it'll be 1.5 plus 62.5. But if I produce so this is for one book. But if I produce two books, it would be 3 plus 62.5. And that's going to be for two books, right? And the difference here is going to be 1.5, right? Because I produce one more book in the second equation, right? That makes sense, right? So, what I'm trying to get at here is that the College Board will ask you what does 1.5 mean here, right? And then they're going to give you answer choices, right? And they're going to be like um the amount of pages the book produces